Please welcome to the stage Dr. Matt Turek, Ms. Teresa Beach, Mr. Orrin Edwards, and Dr. Philip Johnson Fry.
Great, thanks for the continued time and attention. I'm really excited for this upcoming panel discussion, which will close out our morning and take us to lunch. We've talked a lot about learned helplessness, and now we're going to have a discussion about how we can learn to help ourselves to move beyond some of the challenges that we face with current software. And we've talked a lot about the national security implications, cyber vulnerabilities, but there is real commercial and productivity opportunity here, and I think you're going to hear that from the panelists today. So I think this is going to be a great discussion. To get started, why don't we hear from the panelists about a little bit about their background. Some of the folks actually aren't deep formal methods experts, and the path by which they came to start using formal methods. So Teresa, do you want to kick us off?
Sure. So I work at NASA Goddard Space Flight Center as principal investigator for the CAPSTONE experimentation. CAPSTONE is actually a spacecraft in the near rectilinear halo orbit at the moon. Okay? I have no formal methods background. I am a space geek. And the purpose of what we do and my job is basically to lead and develop the navigation, communications, and space cybersecurity technology that we need to improve our space systems, and then also to get it up and get it across the technology, what we call the technology valley of death, to get it up to TRL 7, so that space missions can actually use it operationally. And so I have to be honest and say that, like I said, I'm not a formal methods person, and we came to this because there's a lot of space software, that sort of infrastructure that gets reused and adapted from mission to mission. And of course, as you adapt and you inherit it, you're also inheriting bugs. And it just became a certain point of question of, well, how can we do this a little better? And there was a really interesting experience with DARPA where we had, this was on a previous program, like 5 or so years ago, 7 years ago. And it was basically, we're like, yes, our software is awesome. And then the performers came in and it was like, oh.
So maybe not so awesome.
So we did actually find that there were certain things that we do really well, and there were other things that we learned that were improvable. Let's put it that way. And so that began where we started, and so currently we're going to be transitioning a series of tools from some of the DARPA programs that you're going to hear about today to test them out and actually try to get them across that valley of death. So we can actually put them into actual missions.
Yeah, great. I'm looking forward to that conversation. We're going to talk more about how to get across that valley of death, something that I think we all face. Orrin, how about you? What's been your journey to starting to use formal?
Yeah, pretty simple. It was approximately 3 p.m. on May 10th, 2023, excuse me. So little backstory. So I'm not even even worse, I'm not even a software person. So my role is the chief engineer for a program office for medium altitude UAS. What that means is the MQ-9, RQ-29, and a couple others. So working in a DoD acquisition program office, we don't like change, much less transition of anything. We've got so many requirements, and we're too busy disappointing our stakeholders by being over cost, over schedule, and sometimes performance, and we're just trying to juggle everything to try to deliver some semblance of capability. So when Dr. Fisher in her remarks talked about why program offices don't transition stuff, if you have any questions about that, come talk to me. I am from a program office. I am the problem. So how did that bring us to formal methods? So we had about 3 weeks into my current position 4 years ago, we had a massive implosion of one of our key technical processes. And we took about a year for us to dig ourselves out of that. And we came across, we implemented model-based system engineering tools to claw our way out of that. So after about a year, we're like, you know what, we really need to accelerate this whole digital engineering thing that OSD and the Air Force are pushing. And by that time, we came across, this is where we at a conference, we met with Galois, we got an introduction, and they showed some tools that could automatically lift behavioral models from existing legacy software. So I'm not a software person, that means I'm easily impressed. And I said, I don't have any funding, but what can we do? How can I help? And so we got started with a demo with a company to provide them some of our existing source code, the code that we could provide, and actual code, and they gave a demo of that. Now, it doesn't take a software person to realize that if you can auto-generate behavioral models of your existing source code, the implications that it has for airworthiness certification, for cyber assessments, for testing potentially, shortening developmental tests, we knew right away that this is something we want to pursue. And that's what led us to working with DARPA on the capstone. Thanks.
Yeah, that's great advice. And I think, abstracting away from that, maybe that's the right way to approach this for those of you that haven't started using formal methods. Find a small effort, find a partner, build that confidence in being able to use the technologies like the demo that...
And never let a crisis go to waste.
And also never let a crisis go to waste. So we'll come back to the tipping points, because I think that's also potentially an interesting discussion. Philip, you are a formal methods expert. Can you talk a little bit about how you came to do that and why you find it so interesting?
Yes, so I am a formal methods expert. I got interested in programming languages. Like as an undergrad, I took a programming language class, decided that's what I wanted to do, went to grad school, and then I did an internship 12 years ago at Sandia National Labs, where I now work, and saw the importance of the mission and the consequence of the systems they were developing, and wanted to work on those things, which really need the highest level of rigor, highest level of assurance.
Yeah, great. Oren, you gave a good example, I think, of a tipping point. I don't know, Teresa or Philip, if you have thoughts, like, was there a particular event that sort of catalyzed your use of formal methods, or was it more just coming to a sustained realization of what the opportunity might be? Teresa, Philip?
So I would say, for me, actually seeing the architecture, the scientific red team that was done and the cyber assessment, right? Like, so I'm a NASA engineer, and we don't think cyber. Like, I just have to be honest, we don't. It's not a natural fit, and so it was fascinating and a little bit, it was very eye-opening to see that, at which point I started to say, okay, I gotta understand this a little better. I am not, because I am a space person, and there's very specific peculiarities about space, and when you talk about space and cyber, like there's a whole lot of constraints that we have that you're never gonna see in a ground-based system. And yeah, so that was just a very eye-opening, and I was like, okay, we gotta understand this better. And at that point, I started learning, and then I started realizing, and of course, realizing what needed to be done and what was out there.
Yeah, so for you, it wasn't so much that there was a catalyzing event or a tipping point. It was more sort of coming to grips with the problem and the opportunity.
It very much was, and we were partnered with DARPA at that point, and DARPA had been a great partner, and so I'll be honest, I used the opportunity to learn.
Yeah, great. Philip, what about you? Like, can you say a little bit more about what your organization does and why formal methods are so important?
Yes, so Sandia has a bunch of different mission areas. Broadly, they almost all involve extremely high consequence systems. So maybe the largest and most prominent is our nuclear deterrence role, where we are the system integrator and also design a lot of components in nuclear deterrence systems. And the consequence of failure for those sorts of systems is always going to be extraordinarily catastrophic, maybe beyond any other systems out there, which has driven development approaches all the way through that really treat assurance as the most important thing. And in the last, decade and a bit, formal methods has become a larger and larger piece of that.
Do you feel like some of those exquisite requirements or demands that formal methods helps provide unique solutions to those, because sometimes constraints can really drive creativity or can drive the adoption of new technology.
Yeah, I think it does. One advantage we often have is our systems, many of our systems are a bit simpler. So the trade-off tends to be, we might have more on the requirement side than other organizations would, but the actual underlying digital systems might be less complicated in a lot of cases, which makes it easier for us to deploy methods but not everything looks like that. So there's a diversity of things.
And similar experiences or different experiences from others on the panel on how maybe unique requirements do or don't drive the adoption of things like formal methods. Like, I imagine space has got interesting requirements. Unmanned aircraft has interesting requirements.
So in our sense, probably the two most significant areas that we continually come up short in our software are cyber assurance and airworthiness. So like Teresa said, we treat cybersecurity in program offices, and again, I speak for the acquisition community, we treat it as an ILID that we do at the end of a development program, not built in. And that's the unfortunate reality. And so when we, with the finite budgets that we have for every aspect of the development program, the resources we have for cyber evaluations are finite, they're small, and at best, we can evaluate just the top level code stability for, kind of say the first layer of vulnerabilities. On the airworthiness side, the perception is that to get full certification, like in the commercial world, you'll use DO 178C. On DoD, you'll use Handbook 516. And the cost, the perceived cost to go through those full certification, software certification efforts, in a lot of cases, especially for unmanned systems, is just too cost oppressive. And so from our standpoint, why we're jumping on board with these formal systems tools is because they will lower the barrier to entry on legacy programs like mine.
Yeah, I mean, I think that's a nice point that was also made earlier today about you can't exhaustively test in, yes, we're going to guarantee that the system is never going to do this behavior just based on testing. And so I think formal methods really drives an opportunity to reduce testing costs. Teresa, thoughts?
Yeah, so space processors, like the processors on board spacecraft, are highly constrained. We typically call them space potatoes. Because just to give you all an idea, right? For example, Capstone is out at the Capstone spacecraft, and I want to do one little clarification here because DARPA talks about a capstone. So like the DARPA capstones,
Different capstone.
Totally different capstone. When I talk about a capstone, I'm talking about the spacecraft out at the moon. So my little spacecraft out at the moon, excuse me as I call it mine, obviously, that has actually on board a gigabyte of memory. That's massive. That's absolutely phenomenally massive. Most spacecraft have on the order of like 10 megabytes of memory. And that's to do everything. Fault detection, command, control, telemetry, image processing, all of your attitude control, everything you ever wanted to do on board your spacecraft has to be done with that. And if you want to make any changes, your ability to actually upload a change to the onboard processor, if you have 4 kilobits per second as your RF link, you're styling. I got to tell you, that's like stellar at 4 kilobits per second. So anything you want to upload has to be really small. Anything you want to put on board has to be really small and use a very small amount of power. So everything we do is about how to make it smaller, lower power, and everything. And so that means that from a formal methods perspective, we've had to do, we're trying out, right, like when we tried Rust, somebody, I think it was Kathleen mentioned earlier, the Rust is a memory safe language. So we're trying out, like we're doing some baby steps with Rust, and like the actual Rust application was one thing, and then all of the work that we've been doing has been like, okay, how do we make this smaller and smaller and smaller and smaller and smaller and smaller to get it so that we can actually upload it and test it. So those constraints are what drive us, and we're trying to figure out like how to adapt things to meet those constraints.
Yeah, and again, I think this is a really interesting point that you can apply formal methods, and maybe it's actually a significant advantage in these highly constrained environments. You can deal with some of the toughest problems. So that's been a little bit of a thread on some of the technical challenges in terms of where you might apply formal methods. What I'd like to do is discuss a little bit about some of the organizational challenges, some of the cultural challenges to help people adopt formal methods. Oren, is there stuff that you can share there in terms of like how you convince people in your organization to move out on formal methods? And then the other panelists, please jump in.
The first stage is always accept that cultural inertia exists, and accepting that face on, saying this. So the way I describe cultural inertia is the tools that I learned in middle school are the tools that I'm going to use to retire with. And if DoD really wanted me to change my use of tools, then they would provide those, they would handhold me, and that would be a standard thing, right? So understanding that is the construct that we have to work against. So one thing we've done, and I'm speaking about digital transformation in general, not just formal methods, but in digital transformation in general, one thing that we decided we're going to do is we're going to measure culture. And when you think about it, that sounds, we can't measure culture. Well, the tech companies call that analytics. But what we were going to do is we were going to measure use case attempts for trying a tool on a specific task. And if it worked or it didn't, as long as you brief it to our weekly show and tell, then you're collaborating at an organization level. And by continually tracking those number of use cases, we can run analytics on how many different people are trying things. Are they trying those for engineering tasks, for program management tasks, for logistics tasks? And over time, we can say, you know what, we've prototyped 300 different use cases of applying digital tools in our program. That has been, A, it measures progress, but B, it also puts you in touch with a deeper appreciation of your software problems. So when I joke that we're a walking billboard of problems, it just means that we're in touch with those things that are challenging to us, and we're better able to recognize new tools and how they can apply.
Yeah, and we see you as a good customer as a result of being a walking billboard.
Excited.
So yeah, thank you.
And I actually want to add on to Oren's things. It's the same thing in the space world. I mean, it's your comment about middle school is what I want to retire with is totally on board. Yes. Oh, my word. There's nothing more conservative than like your mission ops manager in a space mission, because they never want to see their boss, because the only time they see their boss is when something went wrong. And so their entire goal in their life is to never see their boss, which means they never want to change anything because they know exactly how it works. So yes, culture. Yep. So I would say, just to pull a little bit on this, is number one, I've learned that I don't talk about formal methods. Like, it's a branding thing. I hate to say it, but it is a branding thing. So I talk about how we're going to improve our resilience to failure, how we are going to harden our software, how we're going to make it better. And we're going to make it better in these measurable ways. Like, that's how I sell it, because I tried with the formal methods and got blank stares.
And also the ability to go faster, I think. I mean, that was something that you related in some of our discussions.
Yeah, very much so. Like, we're trying to improve that as well. Mm-hmm. And so we're trying to measure that. Taking on with the analytics thing, we're trying to compare some of these things and see where we get.
I don't even use the term formal methods because I can't explain it to anybody. so if I
add that to the billboard of problems?
Right. If I can't explain it, then I'm not going to be able to sell that to financial managers, program managers, whatever. So. But I can explain that they are software acceleration tools, and everybody gets that. So that's the core part of my message anyway.
Mm-hmm. And Philip, you're on a different part of the spectrum. What are your thoughts?
Yes, so I think for us, one of the most useful things has been, which is hard if you're building something from the beginning and you do it all right. You don't end up having the evidence of what you prevented. When, in some ways, although it's less the situation you want to be in, when you're going back and fixing something, you do. And all of the stuff you find along the way, like, I think there was someone earlier today had essentially said it's a lot easier to prove something if it's true, right? And in the process of getting to something true, you have to fix all the bugs. So that means finding them all.
And do you feel like some of these approaches to dealing with the culture, is this starting to dig us out of the hole of learned helplessness? Are you starting to see, like, do you have hope? Are you starting to see progress with the tactics and strategies that you're using?
So a saying that we use in the program office, my program office, is, again, regarding digital transformation writ large, is if we had only started 5 years ago, then we'd only be 10 years behind state of technology. Mm-hmm. So, and that is just reality. Again, from a program office, acquisition program office standpoint, we're all change agents to drive change or change agents to resist. And those of us that are really good at resisting, and I'm really good at resisting, it's a massive muscle movement to try to change. Mm-hmm. So what I see is the change, in the next couple of years is not, I don't know, and I'm speaking from a program office standpoint, not so much the technology, but the messaging and the understanding of what these methods and tools can provide to your program, in something that the other functionals in your program office understand and resonate with.
Mm-hmm. Great. I want to turn our attention a little bit to collaboration and partnerships. I feel like that's really important in this space. A very unsubtle message from us about funding available for, finding a partner, coming back with capstone exercises. But I want to start pulling on the value of those partnerships and those relationships, and why building those teams in this area is really important. Many of you have teamed and partnered with DARPA in various ways. Who would like to start the discussion about how those partnerships have worked and kind of the value that you see in them?
So, all right, so I will, because we do a lot of partnerships. We've partnered with DARPA. It's been enormously successful, and we're really, that works really well. We also partner because we develop software that is actually used as part of the infrastructure across space missions. We actually partner across the US government. And so the rest of the government, in a sense, is looking to us to test out these new things, to make things better, to do it faster, to improve, to improve what's being, the capabilities that are being offered. And so for us, that partnership is really critical. And then I want to say the third part of the I view our partnership as sort of like a three-legged stool, if you will. And the third leg of the stool is actually our commercial partners. Mm-hmm. And so the commercial partners in my world sort of get bifurcated into two groups. One is what I would call the more software or component level, which would be, say, for example, formal methods folks like you all, or some of you all anyway. It's also people on my team who developed the software, right, working for contractor support. It's also the actual owners and operators and developers of the spacecraft, right? So part of what we do is I work with the spacecraft vendors. So the Capstone spacecraft is actually owned and operated by Advanced Space, which is a commercial company. And so I work very closely with them to make sure that what we can do on the spacecraft to test things out and to do this experimentation. So from my perspective and my experience, partnership is critical. You kind of got to overshare. It's the conversation again and again and again, and the oversharing in order to build that trust, because once you've lost trust, it's really hard.
Yeah, I really like that point about the importance also of government and industry partnerships. It's not just government to government, and It's not that all the partnerships have to run through DARPA. I mean, you'll hear in talks from PMs later today pointers to tools that have actually nothing to do with DARPA funding. We're really trying to drive the change across the entire ecosystem. Philip, Oren, other thoughts on teaming, partnering either with DARPA, other parts of U.S. government, or with industry?
Okay. Yeah, so it's, I talked about cultural inertia of change, and what that really, one area what that really means is, how do you convince someone to cross the starting line? And no one wants to be first unless you're, sick like myself. But,
Right.
Or we want to be first. I mean,
Right.
yeah.
On something that appears has a perception of being unproven, despite the track record of formal methods-based tools over the last 10, 15 years. But it's in crossing the starting line, it's getting to that, how do you do that in a low-risk way? And we've worked with NASA Armstrong before on some MQ-9 things in the past to do like autonomous flight or airspace integration. We've worked with Air Force Research Labs, other organizations, and in this case, it's in a lot of cases we don't have resources to go after innovation. It's like we don't have a requirement for that, right? We don't have a requirement to improve our processes. We just have a requirement to field something, and so in the partnerships, in a lot of cases, what we've done in the past is a fancy way of horse trading. We don't always have resources, but we have assets and we have people and sometimes some expertise. So in a sense where, working with our prime contractor, General Atomics, where they're doing some IRAD, we can help them with some of the certification steps they need. When we partner with Air Warfare Center, we can provide them some things because they want to do some experimentation. And so the idea of leveraged resourcing is one approach we've used to get across the starting line on a couple of different initiatives.
Yeah, I want to pull a little bit on that one because we've done the same thing. And part of that is capabilities. So for example, NASA, when we're going to invest, it's going to be on space, things related to space technology. So for us, the partnership with DARPA related to the formal methods and everything around that has been enormously productive because NASA's not going to put money in to come up with stuff like that. However, we can transition it and try to make it operational. And in that case, we're partnering with folks like AFRL, RV, for example, to help transition some of these things, or Space Force, SSC out in LA. So that, we're partnering with on the research side for the areas that we don't cover, right? And there's an excellent match there from that one. And at the same time, we're also partnering with other parts of the government and the commercial industry to show, this is what you can do, because we will take the risk on the space side, right?
Yeah. And DARPA's job, I think, is to burn down some of that critical risk early on, show that something is even technically possible, right? And around particularly a game-changing technology.
Right.
So we often build our programs around a technical hypothesis and showing that something technical is possible. But we also think about, what's the impact of the program? We have a goal in mind. We want to change the world. We have a vision to transform the DoD or national security community. We think about that element as well, and we trade those off in the program design depending on kind of where we are. But I think, again, DARPA's role in the space is to burn down that risk and then to partner with others to try and drive some of that out across the broader community.
Yeah, I would add that we're also in a similar situation where we're going to fund those narrow technologies that we directly need, but we also kind of need the whole world to come along and do things more securely. On the other hand, we also, there are places where partnering can be a two-way street. So we have made investments in certified compiler technology where, there is now at least one US government team that has ComCert experience in our own version of ComCert, and we can support some of those capabilities.
Can you say a little bit about what ComCert is?
Yeah, so that was mentioned in the previous presentations, a formally verified C compiler. And so there's a end-to-end correctness proof, and which is very useful in that the machine code that runs on your system is the actual program that runs. It's pretty hard to reason about that. You'd much rather be able to reason about at the source code level, and having a fully verified stack means you can do that and not need to worry about a bug being introduced in the middle there.
So, I think one overarching message for those of you getting started in this area, you don't have to go it alone. That's part of the purpose of the event today, is to drive some of those connections and drive some of that networking, and partnerships will make that easier. And I think there's lots of partnerships to be had to actually move out with the formal methods But places where we'd love to hear feedback is like, here's a place where there's actually too much risk from our perspective, and that's really useful feedback to DARPA in terms of the design of future research programs, and I think also useful for feedback across the broader US government. Philip, I want to come back to you. You've got an interesting role on DARPA's Provers program. Can you say a little bit more about what that role is and how that might be useful to the broader formal methods community?
Yes, so Sandia is the test and evaluation organization for the Provers program, and we broke that into two parts. So one side is about the usability of the tool, and the people who are doing that usability assessment are human factors experts, psychologists, people who understand humans, which unfortunately I'm not. But then the other side is a usefulness assessment to analyze how useful those tools are for achieving different, being able to prove different properties, how much trust they buy us, and so that's been our role in that program. This is just we just finished up the phase 1, so it's still fairly early stages in Provers, but it's been pretty exciting so far.
Yeah. Are there key gaps or needs that you're seeing through that program to make formal methods more accessible? I mean, that was one of the key sort of impact objectives of the program.
Yeah, so I think Kathleen earlier had this chart of where there were different formal methods tools spread out, and on one side there are these very easy to use but maybe not so expressive things like type systems, and the other side there are things like interactive theorem provers, which are extremely expressive but also extremely limited in their user base. And there's a bunch of stuff in the middle. I think one thing we're realizing is that there's also correlated with that is a difference in level of assurance, and that often the things at the end there have a lot of very, very solid assurance arguments. There's not a lot you have to trust. But things in the middle sometimes don't, and that really shouldn't be the case, right? Like, it should be that when you use formal methods tools, they are absolutely rock solid no matter where you are in that curve.
Speaking of, piling onto the usability, discussion. So from a program office perspective, you don't have to go. We don't see as you having to go full bore into formal methods. Mm-hmm. There's a spectrum of usage that you can use them from a very low risk, low impact to full steam ahead. On our side, the easy use case for applicability is a replacement for static code analysis tools. So we all do that to get that surface level understanding of coding errors that could lead to vulnerabilities. But we can also, without changing anything about how we develop software, by applying these tools that can lift the behavioral models and then run those formal methods-based tools on that model, that validated model, we can now, without any change, get a better understanding of our software or cyber posture. So we see it not as we have to jump, it's binary all in or all out. There's really a spectrum of use cases that you can get out of it.
And it's often better, I'll pull a little bit on this, from the space perspective, it's often better to kind of do smaller steps to get used to it and to kind of get people used to it. And part of that, from the space perspective, as I mentioned, we have to get stuff to TRL 7, so that's Technology Readiness Level 7. If we don't get technology, software, hardware, anything that's going to go in space or on the ground that's going to support that mission to TRL 7, the chance that a mission is actually going to use it is approximately equal to 0, okay? So we have to figure out, and that's that, getting from the 4, 5 to 7 is the technology valley of death. And so what we've been trying to do is kind of inch it over little by little by little by little, and do that. And
can you say a little bit more about how you think about, or is there actually a technical definition for TRL 7, and how do you this is perhaps could use up the entirety of the rest of the time.
Right.
But is there a succinct answer to how you think about TRL 7? Or
yes. Okay, I'll give the succinct answer. And just keep in mind, space has its own TRL definitions. TRL 7 in the space world is when you've put something and you've demonstrated it as a as an experiment in flight. So on a mission, it's not baseline for that mission, but it is tested in space, in the environment, and on orbit somewhere.
Yeah, so it's a significant bar.
It's a significant
I'll add a
bar.
definition. It's got to be easy enough for a chief engineer to understand it.
Good definition. All right. All right, so we've talked about various spectrums of tools. Appreciate the comment. I mean, again, Provers is a program that's still running, so that's not a place where, like, not ready for immediate adoption. It's more the look behind the curtain, as Kathleen phrased it. But Philip, I want to pull that thread a little bit more. And where do you see formal methods making the biggest leap in the next 5 years, either from your own intuitions, experiences, or from the Provers program?
Yes, so I do think tools are going to get I'm hopeful tools are going to get a lot more usable. I also think there can be like critical mass effects where once you have enough people using things, everyone is sort of contributing their own little bit. And I definitely think you're seeing that now happening in the proof assistant world, where there's just a lot more math that's been formalized in just the last few years than really any time before. So I think there's an adoption curve that we're sort of on is taking off right now.
Yeah. And Teresa, Oren, I realize you might not have crystal balls for formal methods, but from a user perspective, are there things that you really wish that we had, or are there places where it's like, oh, there's a gap that hasn't been solved yet, or what's your ideal scenario for using formal methods?
So we are in the process of trying to incorporate them into our dev cycle. I can't actually give you any feedback as to how well that's going because we're just starting, right? To actually, because we want to put them in, so that's what we want to try to do. Give me 6 months or so, and I'll have better feedback.
So from my perspective, I can only speak to the objectives that we're building into our capstone program. And again, this is from the idea that even if we don't change our software development process at all, what are the objectives we're going to go after in the near term? From my standpoint, those objectives are, so just, with my Wikipedia level understanding of formal methods, right, you can prove the existence of or the absence of vulnerabilities. And from that standpoint, I can logically extrapolate to say, well, you can also prove the existence or absence of bugs in the development phase before you get to test.
Yeah.
So those two things are pretty powerful from my standpoint. If we can verify software in the development environment, then there's a potential that we can reduce the amount of testing we do in formal DT. And by similar argument, we can, like we already talked about, we can do the same thing from our cyber assessment. So if I can use formal methods to reduce the amount of DT, then I can make the program managers happy because I'm reducing the schedule of their program. So that's what we're setting up in our demo is we are going to run a kind of an experiment against a control where we're going to take a number of prior software releases and their list of deficiencies, and we're going to run an experiment to see if we can detect those same bugs on using formal methods. And then we'll run that through several software iterations and build up this body of evidence to grow confidence in our test team that we can actually reduce test on future programs.
I mean, I'd expand your Wikipedia definition just a little bit, and it's not necessarily about vulnerabilities, but proof of any property that you want for your system. And this is something that we're thinking about very broadly, like the intrinsic cognitive security program that Matt Wilding's running is really thinking about what sort of properties might we be able to prove about an augmented reality system and a human, and really looking to drive forward some of those models on models of human cognitive behavior, which could be interesting for a whole range of reasons. We've got a little bit more than 5 minutes left. I think the place where I really want to spend the remaining time is on that thread of the valley of death. So Teresa, you sort of brought that up earlier. We probably all of us in the audience have heard that phrase before and know how hard it is to try and bridge the valley of death. love to hear from all the panelists on, what lessons should the audience take away from your approaches to how to make these tools useful, how to make them stick in real development workflows. Fine to reiterate some of the talking points that you made before, but I mean, these are I think the key takeaway messages we want to leave the audience with.
So yeah, the technology valley of death is real. I'm going to say that. It's also in the space domain, it's very hard to get over because you have to get something up into space to cross that valley. And spacecraft are not typically done to just do demonstration of something. They are typically sent up to do a mission, whether it's comm or nav or imagery or weather, whatever it is, right? And so really the only time you can do this sort of like testing that you need to get to TRL-7 is once a mission has met its life, it's met its end of life criteria, it's all done everything it's supposed to do. And then I would say the real scramble is to pull together some extra funding, and this is where the partnerships become really key, because if you have a lot of partners who are all interested in the same technology because they're all doing space stuff and they're all using the same kind of thing, it's easier to pool resources and sort of pull together enough funding and say, okay, now we're going to do this little bit of experimentation in the last few months, before we like deorbit the spacecraft or crash it into the moon or send it into the sun, however we're doing it. So then we can all, and by all, I mean all the partners and everybody in the space community then benefits because we can say, okay, we've tested this, we got it to TRL-7. If you're a program office, right, if you're a major program office, now you can say, use this because it's TRL-7 and that's low risk. Anything below TRL-7 is high risk.
Yeah, great.
So my perspective from the Valley of Death is I'm a recipient or potential recipient. And what I see in weapon system program offices is not so much resistance to transition things from the S&T community, it's more indifference. And what I mean by indifference is I got plenty of problems I have to go after. I have plenty of responsibilities on my plate. I have finite budget, I have finite workforce, and innovation really is kind of a nice to have. So what can we do on the program office side? And I've joked before that I am a walking billboard of problems. And when you are in touch with the problems or the challenges on your program, I mean really in touch, it is amazing how receptive you are to performers on the other side of the valley that are working on things that can directly or indirectly you could benefit from. When you're in touch with your problems, you're more receptive to the idea of different partnerships when you want to horse trade assets, via CRADAs or things like that. And so being in touch with your problems really opens your eyes to, it makes you more of a receptive audience to transition things from the other side of the valley.
Yeah, so I think I would add a little bit to that, and just the observation. Well, first of all, I think sometimes you can have a fairly fast turnaround between inventing technology and it being deployed. And when that happens is often when there's a technological need that comes from the mission. And so one thing that happens is sometimes mission scale problems don't show up in the research setting. Maybe because it's too, the scale's not big enough, so things that just have to do with doing something large. Like in programming languages, modularity. It isn't something that's ever going to show up when you are writing really small programs, but is the issue that is going to drive adoption at scale. And so I think that going back to the partnership, there's like tight connections between practitioners who are building actual things and understanding what the driving problems those practitioners have, and making sure your tools address those actual problems. Very important.
Great. Well, hopefully you've learned and thought about some strategies from the panel about how to move from that learned helplessness setting to how to learn to help ourselves. I think there's tools and resources that are being made available to do that. It's not just technical strategies, as you've heard from some of the panelists. There are cultural, organizational strategies as well. One of those is the partnerships that we talked quite a bit about. And part of the purposes of this event is to help catalyze the community, get to that sort of critical mass that Philip and others talked about, so that we can get a takeoff with these sorts of technologies. So really appreciated the input from the panelists. So thank you for those great perspectives and your input. I'd like to thank the audience, great attention throughout, even with the run-up to lunch that we will be at momentarily. Come find the panelists if you want to have some follow-up discussions. We'll be here. We're at a table in the front of the room. You're going to have lunch at your tables. You're already starting that serving process. We've also placed at the tables some cards with topics that might be useful for discussion. So again, we're trying to help catalyze the community here, and so we did a little bit of forward planning. So if you want topics for discussion, feel free to look for those cards in the center of your table. Thanks again for the time and attention. We look forward to the continued discussion.